have a new package. This is our new package. One spool, one reel of LED strips, SMD LED, surface mounted device LED, RGB. So this is RGB type, and it is 12 volts. You can see here the size of the LED. This is 2838. That is the size of this SMD LED strips. The size of this is small, rectangular shaped LED. A very small type LED because this is surface mounted. And then for every section, every cut, there is a cutting point. So for every cut, first strip, this is 12 volts, and we have 9 LEDs in one strips. So one strips, the second one, where is the cutting point. So with two resistor for the R resistor and BG resistor. So blue green resistor and R red resistor. And this one you can see here, G means green color, R red color, blue, green, red, blue, G, RB, then cutting point. Okay, this is one. This is 10 meters long, 10 meters, and it is. Why is it damaged? Huh? You can see here the color coding of the wire. So here we have the ground, black, and then the green, red, blue, green, red, blue, as per color of the LED, RGB. So the black is the common. This is 10 meters, and to work with this LED strips, we need the power. Of course, we have the power supply or the adapter. This is 12 volts to 3 ampere. So you can see here, 3 ampere is the current rating of the LED. Around 12 volts, 3 ampere. For this type of LED strips, which is 10 meters, it includes this power supply adapter of 12 volts, 3 ampere. So all in all, 12 volts times 3 is 36 watts. Voltage times current, 3 times 12, 36 watts of power. For this supply, we're going to supply this LED using this is the European type plug, rounded type, European plug type. And then to the other end, this is the plug, also baby micro plug, power plug for the DC. This type of plug, this is DC plug. And then to work with the blinking or the pattern, we need a driver. This one is the driver or controller. It controls the light of the LED using this controller box. So we have here RGB control box, IR remote control, infrared remote control, input. Okay, we have an input voltage of 12 volts, input 12 volts from the adapter, 12 volts. The output we have, what is the wattage maximum? What is this? 6 ampere maximum. So this controller can be used also with 6 ampere of current maximum. 24 key, 24 controls. Key referring to the remote control. Infrared. So you can see at the output there is a infrared receiver, and then this one we're going to connect it to the LED. There is a marker, an arrow. So there's an arrow to the side. Then to the side also there is an arrow, female to male, 4 pins. So with an arrow. So this one is pogo pins because this is rounded header. Pogo pins. Okay, arrow to arrow. The other one, there's no arrow. There is also an arrow. But here should be the same direction of arrow, not the other one. This one. Let us okay, this is the receiver. Why this is the receiver? Remote control receiver? Because we have this remote control. Okay. Off, on, various colors, RGB, red, green, blue. And then the brightness, the white, flash, strobe, fade, smooth. That is the variation of blinking pattern or the. And then we have this plastic because inside this remote control release the plastic, there's a plastic to protect the battery from discharging. And how can we get so hard. Let us see the battery. You can see here we have the battery. Okay, this is CR1220. Okay, let us now check the voltage of the battery if it is still okay. Using the tester for the DC voltage. What I mean is, okay, DC voltage, brightness. Checking, upon checking this, the negative, positive, let's see this, 3.3 or the negative is in the top or at the side, that is the positive. 3.2, still the battery is okay, 3.3. So I think the battery still works. Button cell battery. And then let us now again put it back. Okay. We have now our remote. Then we need the 220. We can now insert or plug it into 220 volts, which is okay. We are going to plug it into 220. Okay, plug it in. And then for the brightness, I think this one orange. Okay, orange, yellow. What? Yellow, orange. Oh, red. And then blue, plus. This is for the plus mode. The other one, steady, blue. Strobe. This one, strobe. Plus. Plus, strobe. What's wrong with the strobe? Pace. Fade. Fading. Fading. Smooth. Plus. Oh. You can control the brightness. So you can play with the remote control using this remote. Strobe, brightness. There's so many options to choose from. We can play it with the use of this remote. We're going to examine this adapter. It is 12 volts, 3 ampere. It is not heavy. It is very light. What's the inside of this power supply? It seems it is glued. It is not we are going to open the sesame, the box. What? You're just going to open this using a brutal force. To see what's inside. What's the inside of the box? Is this something special here? Let us see. Is there something special in the air? Okay, there is no glue. is being clipped. I think there is no glue inside. Just okay, this is now the very spacious with a small PCB inside, but the case is very big. Why is that so? And there is a spacer that it will and this one is the PCB transformer, capacitor, electrolytic. Then I think we have the bridge type rectifier and a voltage regulator with some resistors, capacitors, SMD type. What is this? Inside is the what? Schutzki diode and D1 Schutzki diode or the diode. Let us they put the foam underneath this transformer because this is the where's the hot side? This is the hot side. This one is the secondary. Okay, this one is the secondary. This is 12 volts. This side is 220 volts. And then there's a margin, space between alternating current and the direct current. Primary, secondary. 220 volts becomes 12 volts. Really? What? Let us reverse engineer this. This is now the actual wirings. Excuse. Power supply, LED strips, 12 volts to 3 ampere. Actual wirings. Where is that? Same with this. Okay. The 220 volts AC. Then the rectifier, capacitor, transformer, then the PWM generator with the resistors. A resistors, Schutzki diode to the secondary, Schutzki diode, then the capacitor. Then the output is 12 volts. So this is the actual, the same with this. After tracing the current, tracing the circuit, we are now have this schematic diagram. So this one, the AC, we have the AC, 220 volts coming into the bridge rectifier. Rectifier, it converts the alternating current into pulsating direct current. Looks like this. Pulsating. And then, with the use of capacitor, filter capacitor, it will make this pulsating into a straight line. Filter capacitor. Feeding to the coil of the transformer that act as a supply to the PWM generator. This one is the IC MT2513 PWM generator. It creates a PWM signal or a wave. Looks like this. On, off, on, off. and it is constantly feeding to the coil, inducing a voltage, and then inducing a voltage, creating a secondary voltage. This is now the secondary voltage from PWM created by the pulsing of pulsing of signal to the coil. It produces PWM to the secondary. It will produce now a small PWM, high frequency signal. And since we have this a positive and negative voltage, and then the negative voltage, we are producing a pulsating DC. After the PWM generates the signal, it will produce a small AC signal, alternate AC square wave. With the use of Schutzki diode, it will just now the pulse is just the positive cycle, or the positive side of the square wave only, because it rectifies the signal. It becomes the half of it, only the positive voltage, no negative voltage, because here after pulsating, generating a pulsating pulse width modulation, it will produce a high alternating square wave, and then induced to the secondary coil. Step down, this one is a step down transformer. Step down from this big frequency to small frequency, and then with the use of this rectifier, just a positive voltage is present now. And with the use of again the filter capacitor, it becomes now DC. It rectifies, it filters the signal. And what is the use of this resistor? This is for discharging the charge of the capacitor whenever we're not using the circuit. So the out now is 12 volts DC. Let us now see the inside of this controller box of LED strips. Okay, this is the inside. We have the port for the 12 volts, and then infrared receiver with 3 lines, RGB, blue, red, green, and black RGB lines. Also there is I think this one is our transistor, and this one we have that is the driver, LED driver, also with the diode and a resistor. So that's all the components inside this control box. We can reverse engineer the circuit. This is now the actual wirings of the control box. Same as this. So we have the remote control receiver, and then RGB lines, 4 lines, and then we have the 3 MOSFET located here, 3 MOSFETs, and then the LED driver IC, a diode, and then resistor, and then the 12 volts supply. This is not 5 volts, this is 12 volts from the 12 volts. And then since we have the actual wirings, upon tracing the connections or reverse engineering, we have now these schematic diagrams derived from this wiring. So we have now the 12 volt supply, the same as this. And then when we press the remote control, this is the remote control, it will receive by the receiver. And then the receiver drives this IC, LED driver. And then since we have the MOSFET, which is the driver for this one reel or one spoon, this 10 meters of LED, this one, that is the LED RGB driver, the MOSFET driven by the MOSFET, the LED, because this MOSFET can able to drive high current LEDs, especially in our LED. So when we press the remote, this one is the remote, received by the receiver, triggering the controller now drives the MOSFET, and the MOSFET now is driving the LEDs. So pin number 5, it drives the gate of the MOSFET, turns on the LED. Once it receives the signal, the pin 5 will drive the gate, open the gate, because the gate now, there is now a voltage developed across the gate of this MOSFET. Once there's a voltage developed because of this IC, it will now, the current now flows from positive to the source, to the gate, to source to the drain, and then the LED, then to the ground. It turns on the LED. It depends on the control. It should be, sometimes it is the pin number 6, pin number 7 that drives the IC, the MOSFET. Okay, it depends on the remote control. So this also serves as a sequencer. So sequencer, LED driver, and the driver MOSFET driver, and the MOSFET is the driver of the LED. This is one actually is the controller, driver, LED driver, okay, controller, sequencer. Once it drives the gate of the pin number 7, it will receive now the voltage, develop a voltage across gate to source or gate to drain, and will now current flows from source to drain. This is also the same as drain to source and source to drain, current will flow. Once the gate opens, the current flows from source to drain. In our case, the design is the current flows from source to drain, because this MOSFET is a two-way components. It's like a two-way outlet. It can flow from drain to source and source to drain. Now drain now is connected the LED and turns on the LED, and then to the ground. Current flows into the ground. Again, also when it triggers the pin number 6, the gate, it triggers the gate of the MOSFET. It will turns on the MOSFET. Current flows from source to drain, and then to the LED, and then to the ground. It turns on this red LED. This one is green LED, red, blue. So it depends on the control of the remote, and being received by the receiver, the remote receiver, and then drives these controls by this controller, and then drives the MOSFET, which in turn drives the LED. And we have this a diode, current steering diode, for protection. I think this is for, not for the protection, just for the driving, steering the current towards pin number 8 and then the pin number 2. And then we have this resistor, pull down resistor to the 8, pin number 8. Sort of current sensing resistor. So that's it. The function is, when we have the remote, we press the remote that received by the receiver. This one is by the IR receiver, and then it now injects signal to the IC, which in turn drives the MOSFET. Then the MOSFET drives the LED, and it will turn on the LED. It depends on the control